Awesome. Well, again, good afternoon, everyone. My name is Remy Gaddis here from Logix Academy, and I'm super delighted to be joining you and hosting this workshop with you. I know it's the last week of school for many of you, or sometimes actually maybe for some of you, depending which province you're joining from. School's been done already. So I first want to take a moment this week to thank all of our educators who have been committed to really continuing to learn, to grow during this time period, and to really be committed for their students and learning new opportunities for their students. As some of you know, Logix Academy is a Canadian company focused on STEM, robotics, and coding. And we have a couple of divisions in Canada that we work on. Our solutions division focused on providing educational solutions, hardware, software, curriculum, and training for educators across the country, programs for students in and out of the classroom and virtual programs, as well as products available in the consumer market. So really, again, delighted to be here with you to share with you different solutions, whether you're familiar with some of our products, or this is all new for you. Really honored to have been working and continue to work with teachers from elementary all the way to secondary and in even makerspace environments in industry. And really with a focus on our curriculum being both code to learn and learning to code. Learning to code really focusing on standards of coding and computational thinking, following international standards. And then our coding to learn is really lesson plans and curriculum aligned to all of the provincial standards in Canada. And you can learn a lot more about that on our website, with, of course, a lot of professional development, both in person when that was capable, when we were capable of doing so, and hopefully returning to do so very soon, as well as obviously online, virtually, and self-directed. As we continue to work with teachers across the country, we've really been able to connect and get teachers to collaborate together through our online community and to really share the best of robotics and coding and what teachers are doing and what you all are doing across the country to connect and collaborate with other teachers. And you could do that right on our online community, which is an open, free community for educators to collaborate, to connect, to share, and to hear about what others are doing. So I encourage you after this, if you're interested, to join the community and join the conversation there. And lastly, this training has been part of our virtual training series, which we launched late March of this year. And we're super delighted to have been bringing a ton of workshops and experiences for educators across the country in diverse topics like this one today. And we want to just take a moment to thank all of our awesome partners who've been collaborating with us and introducing wonderful topics, diverse topics from Flipgrid to Minecraft to remote learning strategies to virtual LEGO robotics to working with Virtual Dash and even looking at students with special needs and how can they learn to code virtually and using the microbit. So hundreds of topics, and we're super delighted to have been offering all those, all for free for educators online. As this is the last week of the school year, there's only a few more sessions left, but if you are interested in any more topics, feel free to jump on and continue to learn online at the website there. And lastly, during this time, and we only have a couple more days, but we've launched the Canadian Storytelling in Minecraft Challenge, which is a free challenge for students and teachers to participate in. And the deadline for submission is actually this Friday, June 26th at 11:59 Pacific Standard Time. So make sure to encourage your students to participate. We already have lots of submissions and are excited about that. And there are over $30,000 of prizes that students can win for their classroom. So make sure to take a moment to join and share that with your students. So without any further ado, I would love to introduce, and I'm honored to introduce Anna Kapint from First LEGO League and First Robotics Canada, who will be leading us today in a session entitled Building and Coding LEGO Robotics using the Virtual Robotics Toolkit. So I know many of you, and I myself actually am a first alumni, let's call it that, and been really encouraged and was motivated to get involved with robotics due to FIRST. So I'm so delighted to see initiatives by FIRST during this remote component and remote time period using this virtual tool. So I'm excited to learn alongside all of you. And again, want to take a moment to really thank FIRST Robotics for partnering with us on this, and for Annika in leading us to all learn and have access to this amazing tool and platform. So without any further ado, I turn it over to Annika, and excited to learn alongside everyone.
Thanks, Remy. Pleased to be here. How's my sound?
It's great. I can hear you clear, loud and clear.
Relief. Okay, and just checking to make sure that folks can see my screen.
Yes, we can.
Thanks for confirming. I may do that a couple more times. Just sometimes when I switch from one window to another, we get a bit of a blank screen. So as Remy said, I'd love to share with you a really powerful tool for building and coding LEGO robots called the Virtual Robotics Toolkit. And I will keep my eye on the chat box. I've seen a couple of questions about the future of this software, which I'll talk about in just a couple of minutes. But first of all, I did want to thank also Remy and Logix Academy for having me here today and to be part of this virtual training series. And most importantly, to you as the educators for your willingness to take time out at the end of a very different kind of end to the school year, when I'm sure it's very busy for everyone. So I'm really excited to connect with many familiar faces. I see out there Miss Kamala and Maylan and anyone else that I've missed. Hey, Miranda and Virginia. And also to meet some new friends from not only that are not only based here in Ontario where I am, but also from Manitoba and Alberta and anywhere else that I missed in case it scrolled by too quickly in the chat. So welcome. Now, I know Remy already invited folks to enter in some ideas about what they hope to get from today's session, so I won't make you do that again. I've been, again, just scanning the chat to make sure that I try and make note to answer any of those questions along the way. But if not, we'll have a couple minutes at the end where you can ask me questions about anything I might have missed. And again, I'm also a learner, so any questions that I can't answer today, as I'm sure you know, I'll follow up with you afterwards. Speaking of the end of the session, there's also a great prize draw. So for those of you that are interested in being decked out in full FIRST gear, then feel free to stick around until the end of the session when there will be a prize draw. Okay, so you probably know, because you read the description for this session, that Virtual Robotics Toolkit is a simulator and it's designed for use with LEGO Mindstorms. It allows users to design, build, program, and test virtual robots without the need for physical equipment or space for testing. And just before I go on, I wanted to address one of the questions from Ian. I don't know if that's you, Ian Dudley, but I'm a Twitter fan, so hey, welcome. You were asking whether or not the LEGO Digital Designer and the VRT would be available for use with the new Spike Prime, which is I suppose, the platform that's going to be replacing LEGO Mindstorms EV3 gradually over time, specifically for FIRST LEGO League teams. And so LEGO Digital Designer is actually no longer supported by LEGO. So my prediction is that they would not be adding in the components that were needed to build build virtually for Spike Prime. And I would just need to check back with Cogmation Robotics, who are the developers of the Virtual Robotics Toolkit, to find out what their plans were in terms of creating virtual robots made using the Spike Prime system. But for you and for anyone who's been participating in things like First LEGO League for a while, you know that some teams are still using the old school NXT, which sort of became not discontinued, but replaced about 7 years ago. And so hopefully this tool you'll still find it valuable for use with the EV3, even if it's not going to be supporting the new Spike Prime. Anyways, hope that answers your question. Let's see what's next. Some of the things that are great about the Virtual Robotics Toolkit is that you can use it in the classroom with few or no LEGO Mindstorms EV3 core sets, so that if you don't have tons of access to that physical equipment, students can still engage in coding and robotics. For those who do have or plan to coach First LEGO League Challenge teams, formerly known as just straight up First LEGO League, this is a great tool for training and skill development, both off season and during the season. Again, if you don't have a ton of the physical robots, it still allow students to engage in the coding and robotics. And there are other virtual competitions in which people can compete aside from First LEGO League using this tool. So today, before today's session, you probably received an invitation to download the necessary software that you would need. These are the companion software to the Virtual Robotics Toolkit. So the one is the LEGO Mindstorms EV3 lab software. I'll show you what that looks like shortly. Also the LEGO Digital Designer that I made reference to earlier in response to Ian's question. And that allows you to build LEGO robots from a repository of virtual LEGO pieces, and also the LDraw software, which is again a library of LEGO parts and allows you to import your own designs into the Virtual Robotics Toolkit. And again, if you haven't had a chance to get these already, there's a website here, a landing page here on the First Robotics Canada website that has links to all of the software or installation files for these software. And so you can get those afterwards and give them a try. As I mentioned, there are a whole bunch of different virtual environments or challenges that students can complete using the Virtual Robotics Toolkit, some of which are shown here, but there's a wider selection that we can take a quick peek at when we get actually into the Virtual Robotics Toolkit. And so today I'm just going to show you some of the basic ways that you can get robots moving in the virtual environment. There are three main ways that I'll show you today, one of which is just using the keyboard keys. The other is using the LEGO Mindstorms EV3 software. And then the third one is using MakeCode by Microsoft, which looks a lot more like Scratch. So it's something with which those of you who are maybe more familiar with Scratch would be comfortable. And we can make the robot do the same thing using both of those types of software in the Virtual Robotics Toolkit. Oops. Okay, so here's the part that I'm nervous about. I'm going to get out of here. And I'm going to try and get into my Virtual Robotics Toolkit. So can I just get a quick confirmation that y'all can see the Virtual Robotics Toolkit user interface?
Yep, you're good.
Thank you. Yes. Thanks, everyone. I wish I could also, not that I'm looking so lovely today, but my camera is actually turned on, and I was hoping to show you a physical EV3 robot, which I'm sure many of you know what that looks like already. But again, it doesn't appear as though my camera is working, so I'll just have to continue with my voice. And so the first method I mentioned in terms of getting the robot to move is using the keyboard keys. I can also use keyboard combinations to change my view. So this is an Alt right click combo that helps me do this rotation. I can also move the platform around and zoom in and out and things like that. But all of that information is in the user guide, and so I won't spend too much time talking to you about that today. I will talk about this first challenge. It's, oh, you can't see me too? Oh, thanks, Adam. I know not to do anything embarrassing. You can, in this first challenge, the goal is to push all of these, I don't know if you can see this, tower off the platform without your robot itself falling off the platform. And so I'm going to click play or start simulation up here at the top. And I am going to use the W, A, S, and D keys to drive my robot towards the tower, but hopefully not so far that it drives right off the platform, which it just did. So it looks like my system is a bit laggy, and even though I press the keyboard keys so often, I pressed it too much. So I'm gonna reset my simulator and see if I can try that again. I'll go a little bit slower. Okay, driving forward with the W key. No, come on back. Shoot, what's going on? Okay, one more try. Come on. Okay, press. No, it's just going so far without stopping. Okay. Usually it is a little bit more easy to control, but you can see that I've somehow managed to maneuver my robot into position to knock over some of those blocks. I am going to keep driving forward until some of them fall off the tower, hopefully without my robot itself driving off the tower. But there it goes. So you can continue to reset the simulator if that happens. And I'll just quickly show you that if that's not working very well, even when things are driving the way they should be, you can also add on some attachments in the same way as you could to a physical robot. And by clicking on this, sorry, I went really quick, by clicking on this option called attachments, and selecting the attachment that I'd like to add from the available attachments, I'm going to try the, let's see, I'll try the V-shaped shovel. And you can hopefully see that it shows you on the robot where it's going to go. I'll add that and click OK. And then if you can see, there's now this V-shaped shovel on the front of the robot that will hopefully help push the blocks off, kind of keep them contained a little bit while the robot is doing its thing. Looks to be working a little bit better now. It's a relief. So I'm going to give this a push off to the edge. Woohoo! Okay, so I was able to clean off all of the blocks. It took 16 seconds, and this is something you could do with students. I'll show you a couple of different examples of activities that have been created that involve some data management and measurement. You can actually change the physics of the blocks and change their mass, and so you can change variables and measure the outcomes just in this one simple simulation. Are there any questions or concerns so far? Again, keeping my eye on the chat, and I trust that you'll add them in there, or just unmute yourself and speak up. It'd be great to hear your lovely voices as well. Okay. And doing a quick check to make sure you can see this next screen, the LEGO Mindstorms Education EV3 Student Edition software. Yes, thank you for the confirmation, Randy, Adam, and Ian. And so in this software, you can actually program the robot to do things autonomously in the same way as you could the physical robot. And I've got a program here created to do something similar to what I was trying to accomplish by using the W, A, S, and D keys in the simulator that I showed you just previously. And so at the bottom are different what are called palettes, and each palette has some different blocks in it that do different things. And again, this is available in things like user guides, so I won't go through the purpose of all of those blocks, but I will show you that I've taken what's called a move tank block, and I've placed 3 of them in a row here. And each one makes the robot do something different. The first one makes the robot drive forward while the wheels turn once. And I know they're going to turn once because my condition here is set for on rotations, and the number here is 1. The 250s represent the power going to the motors, so it also impacts the speed of the robot. So this first block is designed to make the robot travel forward until it's kind of side by side with that tower. The second block is designed to make the robot turn, so do like a spin turn or a point turn towards the left so that it's now facing the tower. And then the 0.6 here means that the wheels are going to turn 0.6 times. Not the robot itself, but the wheels will turn that much to make the robot turn 90 degrees. And there's ways you can measure that to get it precise. I don't know if this is exactly precise. We'll see when we test it. And then lastly, there's a third block that makes the robot drive kind of into the tower and towards the edge of the platform. Hopefully 5 wheel rotations will make sure that it stops before the edge, but that the blocks fall off. So I'm going to see if I can split my screen here. Okay, I'm going to reset my simulator and just get a couple of things out of the way here. So I've got an image here of what's called the brick. Again, I know some of you know this already, but this is, I think you can see this physical robot. So this bit here is called the brick, and into it you can plug motors and sensors. And so when I have a brick like this, if I want to turn it on, I press this middle brick button. And I'm going to do the exact same thing on my virtual robot or virtual brick here. Because what I'd like to do is download the program I just created onto this virtual brick. And I first must connect. So you see on the right side that there's a robot in range or detected called EV3 BRT bot. I'll just click on there to connect up the 2. And then I'll click on the download button to send the program over to the robot. And hopefully you heard that sweet sound of download. Once the program has been downloaded, I can scroll through the menu options here using the brick buttons. And I noticed that there's a folder called Logic's Virtual Training Series. So I'm going to go in there and look for the program called Drive Turn. And I'm going to run it to see if it does what I want. Ready? Okay. Oh, okay. So I was a little bit short, right? Like I didn't even line up with the tower. So in the chat or out loud, do you have any suggestions for what I could change in my program to make the robot do what I wanted instead? More rotations forward. Okay. I like this. How many? How many more? What do you think? Did it make it a half? 1.5, do you mean? 1.5, let's try it. Yes, okay, let me try, ready? So I'm gonna just run it instead of download it and look through the menu for it. Okay, nice. Good guess. Okay, that looks good. So, I mean, the unfortunate thing about this program is once it gets to the end, if it doesn't get all the blocks off, there aren't any more instructions for what it can do. So thanks for that suggestion on the 1.5. That was pretty good. So what I did want to show you really quickly is a program that uses some of the sensors, and it's a little bit more of a, I would say, like, I don't know, efficient or intelligent program, because it actually kind of keeps going until all of the blocks are gone. So I'll just let you look at that really quickly, see if you can decipher that one while I just open a new project over here with a different robot. So what this program is designed to do, it makes use of a loop, a couple of loops, and a switch. And so what it does is it has an ultrasonic sensor on it, or it detects distance. And so the robot kind of scans or sweeps the area to see if there's anything in front of it. Then if the robot detects something in front of it, or if the sensor detects something in front of it, it will start to drive forward. Until it uses another sensor, which is one of the light sensors. It's pointing, it points, I don't know if you can see this, it points down towards the ground, so that if you notice on this platform, there's actually like a white border. And so when the light sensor gets to that border, it knows to stop driving forward so it doesn't fall off. It backs up and then starts the process over again. It does that kind of sweep. So I'm gonna connect up again and see if this does that. Again, just to show you that you can get a bit more complex, and for those EV3 experts out there, you'll know that you can get far, far more complex than this. Yeah, than this program shows. So to answer your question, Adam, do you need to download to a physical robot to use the virtual robotics environment? No, you can just download straight to the virtual robot. But I mean, the cool thing is that you can test your program both on a physical robot, and then you could even like build the exact same robot in LEGO Digital Designer using the same pieces. And I mean, will they perform exactly the same as one another? No, but they're pretty close. Yeah, the physics are pretty good. All right, let's run it. Okay, so I was doing that sweep there. I should maybe make this bigger, sorry. There we go. Okay, so I don't know if you saw that, it got to the edge and it backed up. Then it sees some more stuff as it's doing its sweep, got to the edge, backed up. I think it's not detecting that cylindrical piece that's lying there. Otherwise, it would be driving towards it. So this is something I would need to change in my programming, and or in maybe the physical position of the ultrasonic sensor, so that it could maybe detect stuff that's farther away or lower down. But hoping that gives you a good idea of how you can program the robot to do stuff using the EV3 lab software. I'll just stop this program. Reset. Okay. The next thing I think I'm going to show you, let me just check the time, 2:30. Okay, is also how you could make your robot do the same thing, but using the make code instead of the LEGO Mindstorm Education EV3 Student Edition software. So I'm going to just close out of here and make this a bit bigger. And so just wanted to mention quickly that in the Virtual Robotics Toolkit, there are different views. One of which is called the advanced view. So in the top right-hand corner, I know it's advanced view because I can see all of these tools and features at the top, but there's also a simplified view that I need to go into in order to be able to code this using the make code. So I'm going to do that by clicking F12, just in case you ever need to toggle from one to the other. So you can see that the menu at the top has changed. And then I'm going to press, okay, how do I do this? I'm going to first of all go into a sort of a split screen option that's available in Virtual Robotics Toolkit for folks that are also using a learning management software to access some of the activities. Just so I can press F8 to get my make code access, which I did see there temporarily. So I'm going to go into one more view. And hopefully they will both appear on the screen. Woohoo. Yes, okay. Great. I'm going to make this one out of the way. Okay, so hoping you can see my screen split now horizontally instead of vertically. And I'm going to open a new project and try to create a similar program in MakeCode as we did in the EV3 software. And again, for those of you that have used Scratch, this will look a lot more familiar. And because there are categories of blocks, and the orientation of the blocks is also vertical instead of horizontal, like in the EV3 software. Okay, so I'm going to get rid of this forever block, and I'm going to use the on start block from the loops category. It's just there for me already. And then I'm going to choose a motor block similar to the one that I used in the EV3 software. It's a tank motors block. And if we remember, there were 1.5 rotations it took to get the robot kind of aligned with the tower. It may be different because I've changed the robot, but we'll see how it goes. I can either copy and paste that block, or I can get another one from the motors category. It did it for me. So I do need another tank motors block, but if you remember, one of the wheels had a power of -50 assigned to it, which means that the one wheel will turn backwards and one wheel will turn forwards at the same time. The wheels themselves, I'm going to program them to turn 0.6 times, but that will hopefully make the robot turn almost 90 degrees, and that could be adjusted if given the time. And let's see if I can get another block by pasting it instead of grabbing it from the motors category. Yep. Sorry, folks. Okay, and so then my third block, as in that first program I showed you, is going to hopefully be facing the tower, drive towards it, and as close to the edge as possible without falling off, and we'll try 5 wheel rotations. To run this program, definitely on a physical robot, the way in which you get the programs onto your physical robot is different from within EV3. But for the virtual system, all we need to do is click on play and it should run it. And I'm just noticing that there's some questions there about VRT, which I'll just answer after I play this. Okay, let's check it out. Okay. Okay, so looks like 0.6 rotations is a bit high. Again, it's a different model of robot, and I also noticed that it's very close to the tower, maybe compared with the other ones. So I'm going to just move it back. Let's see if that helps. Ready? Ready. Okay, ready? Oh, it's not. Okay, so it's the turn that we need to fix, not the distance traveled forward. What do you say? 0.3, 0.4? I don't know. Anyway, you can do some trial and error with it. But I'll just try it one more time. Okay, better. Not perfect, but closer. And anyway, the goal is obviously for you to see that the program can be recreated and make code to get the robot to do the same behavior as it did when either driven using the keyboard keys or programmed using the EV3 software. Just wanted to pause and check out some of the questions here. The VRT will not work on a Chromebook, and I know that that's a really popular device in schools, and also have been speaking with Cogmation as often as they'll listen to me about making this more of a web-based application so that you don't need to physically install the software. So, and with respect to purchasing the Virtual Robotics Toolkit, the cool thing is that this software, thanks to investment of CanCode funding by First Robotics Canada, the software is actually available to free to all students and educators. And getting it on your board imaged computers may be another question, but at least for now, while folks are at home, it's free, so you don't need to pay for that. And that website that I mentioned earlier, I'll go back to it, has access, the activation key that you can use to get free access. Okay, so I think I'm gonna come out of here. Yeah, so that was the website I mentioned, and there's an activation code on there somewhere. If you go to the actual website that you can use. So yes, oh yeah, Miranda, for sure. I think also this recording will also be shared with you afterwards. So if it's okay with you, I'm gonna maybe invite some, you know what I'll do? I'll do like this. Can someone drop that in the chat for me? And Deepali, I notice you're asking for the activation key. It's not actually on the screen that I'm showing you right now, but if you go to www.firstrobotixcanada.org/cancode/VRT, and the activation code is there. It's like a 16-digit code separated by hyphens. Yes, thank you, David. But it's all on there, and if anyone would be so kind, I can't type on my little iPad here. If you don't mind typing in the website, or just check the recording later. So. Okay, what I did want to mention is in the VRT, oh, you got it so quick. Thanks, Randy and Lena. Yeah, so in Ian, you notice one is a 60-day trial. It's strange that those are they both on the same website? Because we tried to set it up such that people who have an IP address in Canada get the website that gives you the free one. And because a lot of people were logging in from outside Canada to try and get in on this free software action, we had to limit their access to a 60-day trial. So pick the non-60-day one and you can get more extended access. And as you saw when I opened the Virtual Robotics Toolkit, there were pre-made robots there, and they have a couple of different models depending on the challenge. And we only looked at one of them, but there's a vacuum challenge and a sumo challenge, but they have different pre-built robots. But if you want to make your own, you can still use the LEGO Digital Designer. So I'm going to see if I can open that really quickly, just to show you what that looks like. See anyone on the screen? Yep. And the other cool thing is that a lot of folks online have posted also pre-built models that they made in LEGO Digital Designer that you can open in this software, modify just so you don't have to start building from scratch, and then import into the Virtual Robotics Toolkit. And Miranda, I don't reckon that the link to the PowerPoint will be shared directly, but the recording will be. And so if you navigate forward in the recording to the screen and pause on the one that has the website or any of the other links to resources, I've typed out the whole link as opposed to just hyperlinking it, so you can like type in the sites, the URLs. Cool. Okay, so I'm actually gonna see if I can open a program. Oh, find that. I'm not going to do that today, but what I will show you is that there are different. I don't know how you say, like, libraries of parts that you can open. And yeah, that's what I'm looking for. So I'm going to open the LEGO Mindstorms theme, and then it'll kind of just limit the pieces to which I have access to the ones that are available in the LEGO Mindstorms kit. So if I click on this category, it will show me all of the different kinds of also taking a while to load, but yeah, you can see the brick, and I can bring that into the building environment here. Let's just leave it there. Yep. You can rotate it. I swear. There we go. And you can add different components to it until you get a fully made robot, or like I mentioned, you can import existing models that were created in LDD. And thanks to those of you in the chat who are answering questions about the Mac version for this as an alternative. So the LDraw software also allows you to create models like these and import them directly. So because this one is no longer supported by LEGO, the LDraw might be a good option for you as well. Okay, so all the sensors are here, and connector pegs, wheels, gears, and so on. And then the other cool thing about the LEGO Digital Designer is that you can create building instructions. So, you know, if students build something, they can share those step-by-step building instructions with someone else who can either recreate that with physical LEGO pieces, or alternatively with virtual ones in a software like this one. And as I mentioned earlier, there are a lot of different kinds of competitions in which students can participate, and Cognation is working on I guess like a platform whereby students can enter their scores and show how their skills measure up against other participants from across the world that are using the same virtual robot games platform. And but that's sort of in the works, so stay tuned for that. If this is something with which you'd like to get started right away, there is a resource that was created by Robots Got Talents called STEM Hero, and there's a series of lessons that guide the students through both how to program using the LEGO Mindstorms EV3 software, but also how to use it in conjunction with the Virtual Robotics Toolkit. And that's the link that you can use to check out the course, which you can grab from the recording if you don't see it for much longer. And also, when you go check out the course, there's an opportunity for you to sign up, and then you get access also to this Mindstorms for Beginners introductory guide, which is pretty handy as well. Okay, and some other resources that might be valuable for you is the Virtual Robotics Toolkit curriculum-based lessons. Thanks, Tim. I'm just going to open that one really quickly. The great thing about these lessons is that they can be completed either with or without the coding component. So if you wanted any of your students to just get familiar with using the Virtual Robotics Toolkit, but also have some curriculum connections associated with their tasks, so they're not just like driving robots around, well, I guess aimlessly or for fun, although it is pretty fun. And you may be interested in some of these activities. So in the first one, similar to what I showed you, where they're meant to clear the structure, and they can do that using different attachments and either measure the time that it takes to them to do that, and do some data management, and taking a look at the mechanisms and the different attachments that they add on. And in some of the further activities, as I mentioned earlier, you can change the conditions or the variables and measure the outcomes. So there's some kind of cool math connections there. Some of the other activities involve using the sensors to detect different colors, or even in the case of number 6, following a line. And there's even like a pen option on the virtual robot, so you can like trace shapes and measure their perimeters and things like that. And it's also possible to kind of lay a grid down on the surface of the virtual, I don't know, floor. And so if you're interested in doing some work around Cartesian plane, the Cartesian coordinates, that's an option as well. And there's kind of like a cool probability challenge as well. So you're welcome to look through these resources to see if any of them fit and can be adapted to your grade level. And again, Miranda, the link to these resources is in the slideshow. So if you go to bit.ly/VRT learning activities, you'll be able to access that page directly. And there's also, I mean, he's older now. I think he's probably 18. He's in university at some really like top-notch school because he's a genius. But there's this kid called, I don't remember his real name, but his like YouTube name is BuilderDude35, and literally this guy teach me everything I know about both physical and virtual EV3 robots. But if you really want to know how to use all of the really cool features of this, I would just watch all of these videos. That's what I did, and the link to that resource is in the slideshow as well. And then obviously Cogmation, the people that make this tool, have some video tutorials and a user guide as well. And then lastly, if you want to access that course that shows you sort of the basics of using EB3 and VRT, you can check out that final link. Whew. Okay. So after all that, I'm gonna invite you to use either your existing or a separate device to visit www.menti.com and type in the code 8527, which to me seems short. And I'd love to find out, it's anonymous, so I won't know. How likely are you to try this software yourself and or recommend it to others? It's free. Like we're just, I don't know, it's free. I think it's a really powerful tool, and something that students can do when they either are back in school and don't have physical robots or can't touch them because they're germy, or they can use this at home for a while. I'm just trying it on my own device while I watch the results come in. Just looks like it's working, but I like to enter it. Not enough W's. Well, I'm going to keep using it myself and recommending it to others. Oops. Okay, and hope you'll consider doing so as well. All right. Thanks for participating in the poll. Yes. So just wanted to check in on some of the questions that have come up in the chat. The link to the slideshow, I mean, Remy, I'll send it to you if folks want like the actual Google slideshow, but because all of the slides are shown in the recording that I think you're going to be sending out, that might be a place for you to access the links, because they're all like written out, you know, like the whole URL.
I would recommend as well, if you want to take a moment, Annika, and just copy paste them into the chat.
Yeah.
That would help because the chat stays as record. But yeah, sorry to interrupt. Continue answering. But while we do that, and even after the chat stays active, so then that's a great place to have them there as a dynamic link.
You know, I'm still having that situation where I can't get the chat on the same screen as the one I'm sharing. So I can't copy them over because I can't see the chat. It's confusing me. But, why don't I try and do that while you do the prize draw?
We'll do. We just do have another question. I see a hand raised from Deborah. So Deborah, you can go ahead and unmute yourself and ask your question. Hi, Deborah, do you still want to ask your question? You can unmute yourself and do that now. Okay, maybe we'll continue on. And I see there's another question is, here it says, is the question whether we will use virtual robots? Maybe you want to clarify your question there? Sorry, I apologize. Maybe I missed it there. Oh, for the survey.
Oh yeah, the Mentimeter that I shared. Yeah, the question was, would you use this and or would you suggest it to other people? But it was just for fun, just to see how people were feeling at the end. I think I pasted some very overly sized font links there in the chat. Those are the resources listed on the final page. What else can I?
Thanks for doing that, Annika. And there's another question. It's around FLL. Do you know if the FLL competitions will use the virtual robots, or how will that all work?
Yes, that is yet to be determined. But the likelihood of them using virtual robots is highly unlikely, if not not happening. But there will be, like, coming soon will be clear direction from First Headquarters about some of the different ways that the season could look. I know that we all heard the announcement about some of the different ways the school year is going to work, and I know there's a lot of uncertainty, but we will be finding that out. It's looking as though events might be remote, but hoping that folks can find a way to use their physical robots and somehow submit or showcase their robots' performance and their team's learning, but not necessarily all together in the same space on the same day, but probably not using virtual robots for the competition. And to answer your question about a virtual version of LEGO League Junior, and I actually haven't tried it. I know you can build robots, pardon me, using the same pieces as the LEGO We Do. It looks like they only have, oh yeah, no. Do these look familiar? This is the LEGO We Do 2.0 tilt sensor, and this is like a super old LEGO We Do motor. So it looks as though they have the same pieces that you can use to make stuff using We Do. I'm not sure, I haven't tried to import a model made with We Do components into the Virtual Robotics Toolkit which would be really cool to try. I'm going to open one of the environments in which it might be cool to test it because it doesn't have a lot of other obstacles. It's called the sandbox, and it's just like an empty square. So Miranda, if you end up trying this and it works, let me know. Hey, Margaret. Margaret, that's not you from Manitoulin, is it? Ah, come on. You can't do it on Chromebook though, sorry.
Awesome. So I'm gonna jump in here because it is 2:57. We have a couple more minutes Eastern time here. So I wanted to announce the prize winner, and then we'll continue taking questions if there are any more. So we'll do, first of all, take a moment to thank again First Robotics for their continued support throughout this whole process and through our virtual training series. Hopefully we continue this throughout the summer and the fall. We'll be announcing soon how we'll continue. But again, I want to take a moment to thank First Robotics and the whole team there. And of course, Annika for her time, her commitment, and training us, and her patience in working with us to teach us all here. And so I want to announce the prize winner, number 4, digital drum roll, 427. So it is Bahula Tim Bahula in London. So congratulations. You are the prize winner for today's workshop. I hope you're, oh yeah, it is Tim Guest. Okay, great. So congratulations, and Annika will be connecting with you shortly on all that. And I hope everyone has enjoyed this workshop and enjoyed the experience. And again, thanks to Annika and First for participating. And again, continue with us. If you have any more interest in workshops this week, please do sign up. There's only a couple more classes left. I'm going to stop the recording shortly, but again, want to say thank you. And Annika and I will stick around for a few more minutes if you have any more questions that you'd like to ask.